Hello, welcome back to part 3 of financial mathematics. Okay, by the end of this, you should be able to say I can use the compound interest formula to calculate principal, interest rate, amount of interest, length of loan, and or effective rate of a loan. Okay, so example 20. How long must Pete invest $2,200 at 3.7% compounded quarterly for it to amount to $3,500? So we now have some different information here. We know what the future value is. That 3,500 is what we want to end up with. 2,200 is what we start with. 1 plus 3.7 over 100. That's our interest rate, right? And then it's compounded quarterly, so that is 4 times a year. So this is 4. And then what we got to figure out is the n. So we're trying to figure out how long it's going to take us to start at 22, end up at 35 with a 3.7 interest rate compounded quarterly. Okay, so let's simplify this as best we can. 3,500 equals 2,200 times, let's figure out what this is. It's going to be 3.7 divided by 400, right? So that's 0.00925, so this is going to be 1.00925, right, all to the 4n. So first things first, we want to get n by itself, so we got to start getting rid of some of this stuff. So we got to divide both sides by 2,200, because 2,200 is multiplied by this, so divide by 2,200. And what do we get? Let's see. We get 2,200. Oh, no, we want 3,500. 3,500 divided by 2,200. That gives us 1.5909. And that's going to equal 1.00925 to the 4n. Now, again, our variable is in our exponent, so that means we're going to have to do logs. Log both sides. Log 1.5909 equals log 1.00925 to the 4n, right? And remember, this 4n is going to come out front here, so it's 4n log 1.00925 equals log 1.5909, right? So to get 4n by itself, we got to divide both sides by log 1.00925. Right, so that goes away and we get 4n equals, so let's calculate that out. There's our 1.5909, so let's just do log of our answer. That's 0.201, and then we are going to divide that by log 1.00925, right? And we get 50.426. Now, to get n by itself, we got to divide both sides by 4, right? And we get n equals, so divide by 4, and we get, come on, oh, I forgot to put the 4. Oh, no, there it is. 12.6. So how long is it going to take? It's going to take about 12.6 years. Okay, so that'll take a while. Okay. One last example, but before we do that, let's watch a little funny video.
You do, Chloe. Did you eat lipstick?
Just completed fixing this fence. Try to keep Stella in the yard.
Okay, so example 21. Amani deposits $12,000 in an account that compounds interest monthly. 5 years later, the account has a balance of $16,500. What's the annual rate of what annual rate of interest has been paid? So we're going to end up with the future value, 16,500 equals 12,000. That's a pretty big comma. 12,000 times 1 plus our rate, which is what we're figuring out, divided by 100 times compounds interest monthly. So this is times 12. So this is also to the 12, and then it's for 5 years, 12 times 5. Okay, so we got 16,500 equals 12,000 times 1 plus r over 1,200, all to the 60th power, right? So what we want to do, divide both sides by 12,000, right, to get rid of that 12,000, because we're just going to kind of have to peel everything off until we can get everything away from the r to get r all by itself. So let's see what we get. So we take 16,500 divided by 12,000, and we get 1.375. And that's going to equal 1 plus r over 1,200, all to the 60th power. Now, we want to get rid of the 60th power, so the only way to do that is take the 60th root, because that 60th root and 60th power will cancel out, so that means we've got to take the 60th root of 1.375 as well. So 60 second x root, second answer. So we're taking the 60th root of 1.375, and that gives us 1.000532. I get the right number of zeros on there. Nope, just 2 zeros. 532 equals 1 plus r over 1,200. Now let's get rid of that 1. And we get 0.00532 equals r over 1,200. Last step is multiply both sides by 1,200. And that'll tell us what our rate is. So we take this answer here, subtracted 1, multiply by 1,200, and we get that our interest is 6.39 if we round it off. 6.39% is our interest rate. Okay? All right, that's all there is for this third and final video of financial mathematics. If you have any further questions, please feel free to ask in class. Thanks.